Hello, welcome to the Application Delivery How-To series. My name is Pamela Norris, and today we're going to cover how to enable persistence for HTTP apps. So when we're talking about persistence, also known as a sticky session, we're referring to configuring your application pool so that when an incoming client request is made, they're directed to the same application pool member as long as the persistence is in effect. This can be critical for applications that require client session information to be stored locally. So let's go ahead and get started, shall we? So here we have our AVI controller. Your AVI controller is where we're going to do all your configuration and orchestration tasks when you're managing an AVI environment. Now, one of the first things you might notice is our VIP within AVI is known as a virtual service called web server. Clicking on the plus symbol across from the web server virtual service, we can go in and expand our view. Here we have our web server virtual service, our VIP, connected to a pool. That pool is called web server pool, and that web server pool is comprised of two application servers, named 245 and 246. You might notice some additional objects down here. These are your load balancers, which are referred to as service engines within AVI, and so we can see here that our web server is spanned across two service engines. Clicking on the web server virtual service, and we're going to go ahead and click on the pencil to get a little bit more information on the configuration. The first thing we're going to notice is your application profile. It's set to system HTTP. In order to define persistence for a virtual service, it must be a layer 7. Clicking on the analytics, you're also going to notice that log all headers and non-significant logs have been selected for the purposes of this demo. So if we click on pools, and we see our web server pool is listed, we're going to click on that pencil once again to view the settings. We're going to see that the load balancing algorithm has in fact been changed to round robin, and no persistence has been defined. So if we click on our application, 233, we update it a couple times. Go back to the controller, click on virtual services, click on your web server virtual service, and this time we're going to click on logs. Non-significant logs. We can see right here our client IP ends in .21, and that 233 VIP gets SNATed and sent to the 245 application server. 21, 246, 21, 245. So during the duration of your HTTP session, the traffic is being load balanced from the client to the backend applications via round robin, exactly what you would expect to see in a round robin configuration. So now let's go in and define some persistence. We're going to click on pools, going to click on the pencil, and we have this persistence field. Now if we click in there, we're going to see that we have 5 predefined templates within AVI. For persistence, we have your HTTP cookie, your app cookie, your HTTP header, TLS, and client IP. Now outside of these predefined templates, you also have the ability to configure persistence with consistent hash or also utilize data scripts. Data scripts are the way to write additional code to have advanced features and functionality that may not be available via a feature or a policy. Sometimes people will utilize data scripts with persistence to insert their own unique identifier on which they want to achieve persistence on. For purposes of this demo, we're going to go ahead and select HTTP cookie. Clicking on that pencil once again to see the settings, we can see we have a couple of options here. What's going to happen if the persistent server that you're being directed to is down. The cookie name. Make note of that. This particular cookie name ends in KT. That's going to be important in a little bit. And again, you can set your persistence timeout. So if you don't set your persistent timeout, what's going to happen is persistence is going to be maintained through the duration of your HTTP session. Click it on the X, and now we want to save that change. Going back to your application, and we're going to go ahead and click on it 3 times. So now if we click on our AVI controller, click on your virtual service, click on your web server virtual service, and click on logs, non-significant logs. Now if we look at our most recent 3 entries, click on the little plus symbol to expand, we can see the client IP that ends in .21, once again being sent to 233, SNATed is sent to application pool member to 245. Click on the plus symbol to see the next bit of traffic, again .21, virtual service, SNAT, and you'll see, unlike before when it was going back and forth between 245 and 246, now everything is being directed to 245 from that same client IP address for the duration of the session. Now if we log into this or look into this a little bit deeper, we select View All Headers. Now this is a traffic that was generated immediately after the change. You'll see what has occurred is the response from the header received from the server to the client now has a set cookie that has been added to it. At this point in time, nothing has been added here yet, but this entry has in fact been made because of the change. So if we look at the additional traffic that has occurred after that, again going into View All Headers, you can see now that the traffic from the client to the server now has that cookie entered. So as long as that cookie is embedded into the header field, the session will maintain persistence. And that is how you achieve persistence with HTTP apps within Avi. Thank you for watching. Please check out our other exciting videos in our Application Delivery How-To series.